Yes, I hope the screen is clear to you. And now, so I wish to first tell you, and the topic we are going to discuss is differentiation of one function with respect to another function. Little bit basic. It will not take more than 2 minutes, but it is the basic for you.
Okay.
So let me just take one more step. So basically, firstly we will be discussing question based on this. What you will see, there will be a function. Let me just choose the pen. Yes, there will be a function like u defined in terms of fx. There will be a function v defined in terms of gx. Both are defined with respect to the same variable x. The question is, you need to find du over dx. Du over dv, sorry. You can apply the chain rule. It is du over dx into dx over dv. This second expression you can rewrite like multiplied by 1 upon dv over dx. So when you combine this, the ultimate formula you get, in the numerator it will be du over dx, and in the denominator it will be dv over dx. Do you agree?
Yeah.
So there is a question given to you in 3.50. It is a straightforward question. I'm not so much interested because it will be having direct calculations. So, but for the moment, just suppose u is log of sin x.
Yeah.
What is the derivative of u with respect to x, please? What is the derivative of
So
u with respect to x?
1 upon sin x into cos, so cot x.
Perfectly okay, cot x. You're right. And what is the derivative of dv over dx?
Um, 1 over 2 cos 2 square root of cos x into minus sin x. Yeah.
So now you have to only plug the values. du over, sorry, it should be du. So du over dx, it is a straightforward formula. It is going to be cot x divided by negative of sin x divided by 2 square root of cos x. It will not take you hardly 30 seconds for you. You will be able to get the answers.
Yeah.
Right? Now, onwards, I'm interested in these type of question, and in the exercise 3.6, you will see questions like this. So you have trigonometric expression. Let me just denote by u. Tan inverse square root of 1 plus x square minus 1 divided by x. And another expression is v equals tan inverse x. If you ask me what is dv over dx, it is a straightforward formula for you. Can you please help me? Is it so?
Yeah.
So I don't have any issue with v, but if I ask you to do the same and you consider this whole expression as g, so du over dx will be too much for you, like 1 upon 1 plus u square if it is u. So this is going to be something very uncomfortable. So there should be some technique involved. So whenever, most of the time, inverse trigonometry functions are there with some expression like this, it is always better to substitute if you can. So like 1 plus x square is given to you. So whenever 1 plus x square is given to you, for me it is better if I can substitute x equals tan theta.
Yeah.
Okay. So if I substitute like this is going to be tan inverse 1 plus tan square theta minus 1 divided by tan theta.
Yeah.
Right?
Yeah.
This is going to be our tan inverse 1 plus tan square secant square, And if
Yeah.
you take the expression out of this square root, you will be having secant theta minus 1 over tan theta. Now, how should I simplify this expression? I think it is going to be an easy and obvious task for you. Just convert them in sine and cos, try to cancel out some common terms. This is going to be 1 over cos theta minus 1 divided by sine theta over cos theta. So it is going to be tan inverse 1 minus cos theta multiplied by cos theta over sine theta. Do you agree?
1 second. How did you get that? Sorry, what did you get?
Okay, so I have not done anything special. Secant theta is 1 over cos theta.
Right.
Can you please check? And
Yeah.
tan theta is sine theta over cos theta.
Yeah.
So numerator 1 upon cos theta minus 1, you just take the LCM, it is 1 minus cos theta over cos theta.
Okay.
No issues?
Yeah. Good.
And this sine theta over cos theta, it was in the denominator. I will just write like multiplied by the reciprocal of denominator. Okay. So if you can see some common terms can be cancelled out, you will be having like cos theta cancel out with this cos theta. You will be having tan inverse 1 minus cos theta over sine theta. Now, I told you that cos theta and 1 are anti of each other. So 1 minus cos theta, if you ask me, I will write 2 sine square theta by 2. Divide by and denominator. If I'm just having half angle in the numerator, I should do the same in the denominator also. I should be able to write 2 sine theta by 2 cos theta by 2 in place of sine theta. Agree?
Yeah.
And sine theta cancel out, 2 cancel out. So what will you have? You will be having tan inverse of sine theta by 2 upon cos theta by 2 is tan theta by 2. And tan inverse will cancel out this tan. You will be having theta by 2.
Yeah.
Okay. So we are doing all these things to simplify the expression for you. What was your theta? Theta was from this expression tan inverse x. Am I right? So
Yeah.
let me just write tan inverse x. So basically, whenever you get an trigonometry expression, you should somehow, after substitution, simplify the expression. So now if I ask you, tell me what is my du over dx? You will tell me 1 by 2, keep it as it is. The derivative tan inverse is 1 upon 1 plus x square. So du over dv will be, it is du over dx divided by dv over dx. dv over dx you already have. du over dx just obtained, right? What should be the final answer? What should be the final answer?
Oh, I see. And what's? Oh, I see. 1/2.
1 by 2. Perfectly okay. You are right. So what is the learning from here? Whenever you have inverse trigonometry involved, you should try to simplify them.
Yeah.
Make sense? Okay, so let me just give you one more idea. This is a question from the exercise based on the similar structure. So find the derivative of the first term. Consider the first term as u. And let me just write down. It is going to be tan inverse 2x over 1 minus x square. And the second expression is v, which is sine inverse 2x upon 1 plus x square. Okay. Important thing, mod x is going to be less than 1. Can you please tell me, do you know some trigonometric for expressions or functions which may have values near about less than equals to 1?
Yeah.
And can you please tell me what are those trigonometric
Yes.
expression?
Isn't it like 10?
Yeah. Basically, tan theta for certain values also follow the same rule. Sin theta, cos theta also follow the same rule. Now, please try to help me. What should I substitute here to simplify the expression? Let me just tell you, if you can, just a second. Do you know what should I substitute, or should I tell you?
I think you can do
Okay, let me tell you. In these type of questions, so either you have an expression like 1 plus x square, something like that, we can substitute. In this question particularly, I can tell you there is a formula tan 2 theta is going to be 2 tan theta upon 1 minus tan square theta. Can you see this side and the right hand side of u
hmm,
almost the same?
yeah.
So I should substitute x equals tan theta there. So in this case, I should put x equals tan theta. And what about the limits? Limits I can manage. So they will be the limits on theta. So my u is going to be tan inverse 2 tan theta upon 1 minus tan square theta. That is tan inverse tan 2 theta, and tan inverse can cancel out. It is 2 theta only. This is going to be 2 tan inverse x. Do you agree? From here, the derivative is obvious task for you, right? Do the
Yeah.
same for the next. And before this, let me just tell you 2 tan theta upon 1 plus tan square theta. This is the formula of sine 2 theta. Okay. 2 tan theta
Um,
upon 1 plus tan square. It is the formula of sine 2 theta. So what is the suggestion here? I should put x equals tan theta in V also. So let me just put x equals tan theta, or theta equals tan inverse x. So I will be having sine inverse. How much should I write? It is 2 tan theta 1 plus tan square theta, which is equals to sine inverse sine 2 theta. Sine inverse will cancel out with this sine. You will be having 2 theta, which is same as 2 tan inverse x. From now onwards, can you please take the question and tell me what should be my du over dv? I have simplified you. I simplified v. Please help me with du over dv. Quickly.
okay. DODV. I think that's just 1.
Perfectly okay. No issues are there. Okay. So perfectly, no issues are there. So is it done? No issues?
Yeah, it's clear. Yeah.
Perfectly okay. Okay. Give me a second. Let me just think about the other question. So you will be able to find these type of questions, plenty of question actually, in any local textbook for AP calculus. But yes, there will be some other text. There are two terms like secant inverse and other term. Other term is without trigonometry function. I will not substitute anything here, but I should substitute anything, something to simplify u. What should I substitute here?
I think you can do cos. You cos
Perfectly
together
okay.
cos 2x.
Perfectly okay. You are absolutely right there. It is secant inverse. It is going to be 1 over 2.
Mister, can you give me 1 second? Yeah, give me 1 second.
Please.
I'm back. Yeah.
Okay. So what I have substituted, I put x equals cos theta. And like you told me, this is going to be secant inverse 1 over cos 2 theta. 1 over cos 2 theta is going to be secant 2 theta. Secant inverse will cancel out the secant. You will be having 2 theta. That is 2 cos inverse theta there. V is given to you like square root of 1 minus x square. From here onwards, you need to take the question. You need to find du over dv using the expression du over d theta. Oh, sorry, I made a mistake. It should be x there. And it should also be x. Divide by dv over dx. Whatever the expression you obtain, at the end, you need to plug x equals 1 by 2. Because this was the question. Find the derivative at x equals 1 by 2. Can you please take this question now onwards? Tell me the answer, and then after we'll move to the matrix part.
Okay.
Okay.
Yeah. You mean determinant, right?
Yes, we will proceed for the determinant.
Okay. What's the differentiation of a sec inverse?
See, it is cos inverse. It is cos inverse. And if you ask me the derivative, let me just write down. Du over dx is going to be derivative of keeping 2 out. Cos inverse is going to be negative 1 over square root of 1 minus x square.
Okay. And then v would be 1 minus cos squared. Okay, fine.
V is only square root of 1 minus x square. So you need to take a simple derivative here without simplifying anything.
Oh, okay. Fair enough. Fair. फिर I think हो जाएगा minus 1 over 1 minus x squared.
Just tell me once more, what is dv over dx?
1 over 2 into 1 minus x squared square root into minus 2x.
Perfectly okay, perfectly okay. 2x will be cancelled out.
Yeah.
So the derivative will be having 1 over x only. Am I right?
Oh,
If we just
yeah, you're right.
divide the numerator and denominator, it will be the same. So now just plug the value. X equals half. It is going to be 2. This is the answer for you.
Okay, that's nice.
Okay. So I hope you should be able to try question based on 3.6. Example number 3.52 and question number 4 are going to be related. So my request to you, you first try. If you find difficulty, I'll tell you in the next class.
Okay.
Okay. Next, let us just talk about the determinant and how should we deal with the determinant. So let me just take you to 2 by 2 and 3 by 3 cases separately. So just suppose it is determinant given to you. What is a determinant? Determinant is nothing but a real number. Okay. And it will, if it is a real number, we should be able to write in an expression like we used to do before. So certainly we know the expression. How should I write? It is a11, a22 minus a21, a12. So we are writing this. So why it is special? Because this determinant is related to the square matrix. Okay, it is related to the square matrix.
Yeah.
Now, what is the question here? The question is, if there are some terms which may be a function of x. If there are some terms which may be a function of x. So they should be able to, we should be able to differentiate. The answer is yes, we should be able to differentiate. How should I differentiate this one? So the answer lies here. If there is a derivable term, not all the terms are constant, then it is going to be 0. You take the derivative of the first row, derivative a11, a12, keeping second one as it is. Then after, do the derivative of second row, sorry, keeping the rest as it is. And I will be following the same rule for 3 by 3. Okay, I will be following the same rule for 3 by 3. Any doubt?
It's clear.
It is clear. I hope no issues are there.
Oh,
So
you
give me a
do
second.
A11, A12 prime, then A21, A22 prime.
Yes, yes.
Okay, that's
So
not bad.
this is what, and let me tell you, if there are 3 rows, I'm going to do the same. Differentiate first row, then second row, then third row. So there will be 3 elements. Okay. So you have a question based on the same. This question number is 3.5.3. But yes, as you know, you need to get the value of the expression. For that, you need to simplify. Simplification is a task we will discuss later on. For the time being, there is a function fx given in terms of this determinant. You need to find the derivative at 0, derivative at pi by 2. First of all, help me with the derivative of x. So writing the same expression, just differentiate the first row. Derivative cos, okay? And
Okay.
just a second. They may have done something. Okay. Give me a second. Give me a second. Okay. See, one more thing, actually, the same rule can be applied for columns also. If you wish to apply for the column, differentiate the first column, then after differentiate the second column. You can apply the same rule for columns also.
Okay.
Are you getting the point? You can apply the
Yeah.
same rule for column
Column.
also. So we can, yes, this is the statement. I forget to tell you. They have written this statement. So, and the expression they are writing for 3 by 3. Just suppose there are 3 columns, column 1, column 2, column 3. Derivative will consist derivative first column, derivative
Okay.
second column, and derivative third column.
So kind of like how we did for rows, but this the other way around.
It is up to you. You want to use row, you want to use column, it is up to you basically.
Okay, won't make a difference now.
Yeah?
Difference नहीं बनेगा ना? It
No,
won't
no,
make a difference.
no,
Okay.
no. It should not be a different term for you.
Okay.
Okay. But yes, because see, simplification of derivatives sometimes need some skills, like they may not be straightforward. So for that, you need to just get the answer. So this particular question, they are trying to use this column version. So let me just differentiate the first column. Derivative cos is sin x. Derivative of cos 2x is going to be negative of 2 sin 2x. And derivative cos 3x is going to be how much? Negative of 3 cos, not cos, it is sin 3x. Differentiating the first row, keeping, so first column, keeping rest as it is. Three cos 3x. What will be the benefit of doing like this? You will ask me what is going to be f prime 0. So I will plug 0 in place of x. Always remember sin 0 is 0 and cos 0 is going to be 1, right?
Right. Yeah.
So sin 0 will 0, sin 0 equals 0 will make this column 0, and whenever there is a 0 column, the determinant of that expression is going to be 0. Okay, so that is why this expression is going to be useful for you. Do the same for the next. Now keeping the first as it is, cos x, cos 2x, cos 3x. Derivative sign is going to be cos x, 2 cos 2x, and 3 cos 2x. Later cos x, 2 cos 2x, 3 cos 3x. Okay.
Yeah.
Now observe one more rule from the determinant. If there are 2 identical columns, what should be the determinant? If
Determinant.
it should be 0.
अच्छा
whenever either there are two identical rows or two identical columns, the value of the determinant is going to be 0. Agree?
yeah
Okay, so these rules may be useful for us. What should be the third expression? Please help me. Dictate me the
third
first column is the same.
yeah
Second column is same.
yeah
Sin x, sin 2x, sin 3x. And the fourth column is going to be how much? The derivative cos in negative of sin x.
yeah
Negative of 4 sin 2x.
yes
Negative of 9
9
sin
sin
3x.
3x yeah
Okay. Now,
so I think
after,
so बस ऐड करना सब कुछ
no, adding is not like this. So this is what
नहीं
adding stands for. You first calculate the value of each determinant and then add.
हाँ like
And
वही मेरे ख्याल
yes, I told you this expression is going to be 0. Do you agree?
yeah
So even if I remove this, there will be no issues. Now,
okay
my request to you, plug the derivative, sorry, plug x equals 0 in the expression of the derivative.
okay
The
let me do
first one
that
is going to be 0, 0, 0.
0 0 0
Rest two
0
columns are same.
0 0
Am
0
I right?
yeah yeah
Basically, there are two columns having 0, 0, 0. Third column is same. Second determinant is already 0. Third determinant is going to be the value is 1, 1, 1, 0, 0, 0, and 0, 0, 0. What should be the value of the expression?
0
And the reason being why it should be 0?
because third column में भी दो rows 0 है दो column
Perfectly. No, no. See, whenever there is a 0 row or there is a 0 column, the value of the determinant is 0.
oh अगर
Clear?
कोई भी हो like कोई भी
हाँ,
row
कोई भी
column
हो. And in case, like in this case, there are two identical columns. So whenever there are two identical columns or there are two identical rows, what should be the answer?
अच्छा तो वो भी 0 होता है
हाँ, ठीक है. So इस तरीके की कुछ properties हैं आपके के पास में. So if we get time to do those, so we will be doing that. Okay.
yeah
But for the timing, you just focus on derivative, something like that. Now, my request to you, just look at the same expression, just plug pi by 2 in place of x and do the same calculation. Can you please give it a try?
yeah
Sin pi by 2 is 1.
sin
Okay.
pi by 2 नहीं वो
Sin,
minus 1 है ना minus sin pi by 2
sin, sin pi by 2 is 1. Sin pi is going to be 0. And sin 3 pi by 2 is going to be minus 1.
okay
Okay,
got that
these are the hints. Sorry, yes, I think you are right. Just plug the values and do the basic calculation. Send it to me, whatever the working.
yeah cos pi क्या होता है cos pi
Cos pi is going to be, let me just write the values for
minus
you.
1 sure
Just a second. Yes. Cos 0 की वैल्यू आपके पास 1 होती है, which is equals to cos 2 pi. Okay.
yeah
Cos pi की वैल्यू आपके पास -1 होती है. Cos pi by 2, cos 3 pi by 2 are going to be 0 for you.
okay
ठीक है. Sin pi की वैल्यू 0 होती है. Sin pi by 2 is 1 and sin 3 pi by 2 की वैल्यू -1 होती है. Just note down the values. Try to plug the values here. Try to tell me.
okay वो ये निकालिए डिफरेंशिएशन बस सब वैल्यू निकालना है
हाँ,
तो वैल्यू में हो गई सर जो डिटरमिनेंट निकालना होता है उसमें पहले प्लस से शुरू करते हैं माइनस से
पहला प्लस वो इट इज डिपेंडिंग अपॉन विच रो यू आर फॉलोइंग. फर्स्ट रो के लिए पहला प्लस, दूसरा माइनस, तीसरा प्लस.
ओके आई थिंक सब कुछ मिला के 11 आ रहा है 11
गिव मी अ सेकंड.
बराबर
It is going to be 4 there. Let me just share with you.
show me है थोड़ा सा लाइक आउट ऑफ टच डिटरमिनेंट बस लेकिन
Oh,
या हो जाएगी.
no issue, because we are discussing right now. इतने difficult task नहीं है. So after plugging the value pi by 2, these two should be the determinant, because middle वाला तो 0 हो ही गया था आपसे. When you just expand them, ठीक है, कभी जरूरत पड़ेगी तो हम लोग डिटरमिनेंट को सॉल्व करेंगे, वैसे आपको इतनी जरूरत पड़ने नहीं वाली डिटरमिनेंट की.
Okay.
ठीक. So there is a simple and similar question for you. तो yes, क्वेश्चन को थोड़ा ध्यान से देखना, because look at the question. Can you just tell me if you have observed anything related to this question? कुछ ऑब्जर्वेशन किया आपने यहाँ पे?
ये यहाँ पे लिमिट है, लिमिट लगा.
लिमिट लगा हुआ है. Okay, just try to help me. Whenever there is a determinant term और इसमें किसी टर्म से मल्टीप्लाई होती है, so we have a choice. We can multiply this term with a row, particular row, or a particular column. So मेरे पास में यहाँ पे 3 कॉलम्स, आपके पास में x, x square x, 1, 2x, 1 there. So I wish to multiply this term with column 2. It is my choice. Why? Because simple terms containing x are there, x or x square. There will be a better expression. We can cancel out some terms, some exponents. Cos x, 2 sin x and 10x. Divide करेंगे 1 x 1, 1 2x 1. Agree?
Yeah. Yeah.
Now I'm asking you, tell me what should be limit x tends to 0 fx over x.
It's एक कंफ्यूजन. हमने ये कैसे किया? हमने सिर्फ सेकंड कॉलम को कैसे डिवाइड किया?
See, let me just tell you once more. Whenever there is an expression given to you like this a, and you wish to multiply in determinant, there is a choice. You can multiply this a with a column or with a row of your choice. Of your choice is important. Out of these three terms, I can see that there is a second column having x, x square and x. So I can, if I multiply by 1 by x, I can simplify them easily. So I chosen the second column to simplify. Okay, this is a property. If you need more, we can discuss maybe in the next class what are the properties, so that the things will be more clear. For the time being, if there is something, you can multiply with a row or with a column of your choice. Now just plug the values. So cos 0 is 1, 1, 1. Sin 0 is 0, 0, 0. Tan
सर
0
आपको
is 0, 1.
आपको
What?
डिफरेंशिएट.
I'll tell you about the differentiation also. You just focus on this one for the moment.
Okay.
So because there is a 0 row, so I can tell you the value 0. Right?
Right. Yeah.
Now, in the book, they have obtained this expression using the derivative. And how they are using it, let me just tell you. Before doing anything, try to help me. What is going to be f0? Just plug x equals 0 there. There will be a 0 column. Second column will be completely 0. So answer is going to be 0. Any doubt?
Yeah. That's good.
So if it is good, let me tell you, the derivative of a function is defined as limit x tends to 0 fx minus f0 over x minus 0. Do you agree?
Yeah.
This is going to be the derivative at 0, sorry. Right?
Correct.
f0, you already know the value is 0. So it is the same expression like fx over x. So in order to find this term, I should find the derivative there. This is what they have done in the book. You got it?
Mm-hmm.
Give me a second. Yes, now it is better. So now the question is for you. This is the expression given to you. You please differentiate column wise, row wise. It is your choice. Plug the value 0 there and do the task. You have got 2 minutes to simplify. You know how to differentiate. You can differentiate row wise. You can differentiate column wise. Okay, please do it. This time they have differentiated row wise.
Okay, so differentiate like the original function. No?
Yes, it is up to you. Row wise or column wise. There will be
No, I mean
three.
the original function or the simplified one.
What original function को simplify करना है कब? I didn't get
लेकिन
that.
ये वाला जो आपने किया था वो सेकंड कॉलम को 1/x से मल्टीप्लाई तो मुझे उसको
No,
डिफरेंशिएट करना है या पहले वाले को करना है जो
no, no.
पिक्चर में दिखा
See, I have given you two ways to think to solve the question. This is one way without the derivative. I told you the answer is coming out to be 0. Okay.
ओह
This is another way of doing the question. This way is followed by the book, and this was
ओके
the way without the book.
ओके सो
Okay.
so just
You
कॉलम
have a
पे
function.
हाँ मैं बात से
You have a
डिफरेंशिएट
function.
करूंगा
Differentiate
हाँ
करो and try to get the answers.
ठीक कर ली डिफरेंशिएट अब सॉल्व करूं
Just just
अब
plug 0 there. Just plug 0. Try to simplify. You should be able to get the answer. There is a question number 3 based on the similar structure. There is a question number 3 in the exercise 3.7. It is based on the same structure.
okay
Done?
yeah it makes sense I'm almost done yeah
So if you look at number 3, gx is given to you. Just try to observe what should be your g0.
g0 मतलब f of c
F of c,
f of
f of c,
2c oh yeah
f
sorry
prime
yeah
c, f2c, f2c, f3c, f3c. Rest is going to be the same. I'm not interested. What is the observation here? There are two rows, two identical rows basically, right? And
yeah
whenever there are two identical rows or identical columns, it is going to be 0. So again, so I know that derivative at 0, I should use the correct expression. G prime 0 is going to be limit x tends to 0, gx over x. You got it?
yeah
So you need to get the derivative and then plug x equals 0 there. You wanna give it a try? I'm giving you 2 minutes to simplify the question.
okay
Okay, you just take 2 minutes, try to simplify this question, and if possible, send me the working.
so I want me to differentiate correct
Yes, you need to differentiate this ex, and then plug x equals 0 there, you will get the answer.
okay wait can you walk this out a bit or can you like work this out
You want me to differentiate?
yeah
Okay, so give me a second. So for me, this is derivative at x is going to be differentiate the first row. It is derivative x plus c. The derivative x plus c is going to be 1. Derivative x plus 2c. The derivative x plus 2c is again 1. So only the derivative sign will be there. Rest are the same. It is fc, f2c, f3c, f prime c, f prime 2c, f prime 3c. Any doubt?
no
Now differentiate the second row. So you will be having derivative at C, derivative at 2C, derivative at 3C. Third row is the same. Keeping the first row as it is. Okay, why I'm just showing you this? Because you should be able to observe row number 2 and row number 3. They are going to be identical, and whenever two rows are identical, the value of determinant is 0. So this expression is completely 0. Got it?
Yeah.
Next, what you do, you just try to differentiate the third one, keeping the first two as it is. So third one derivative, double derivative C, because already one derivative is there. Double derivative 2C, double derivative 3C, and oh my God, I made a mistake there. It was a blender mistake. What should be the derivative of f prime C? Should it be 0?
With y.
That is an easy observation because C is a constant. So whenever
Oh,
you
right.
plug the value C there, it becomes a constant. And the
Yeah.
derivative constant is going to be 0. Okay?
Yeah.
So I will be getting 0 and rest are going to be the same. So now, because last two determinants are going to be 0, if you ask me what is G prime X, it is going to be the first expression only. Okay? Now I'm asking your help. Just plug X equals 0 there and try to get the limit answer. Please solve. Try to get the answer.
0.
And why it is 0?
Because once you put x is equal to 0 for first row, it becomes same as second row. So
Yes.
that's.
No, third row. First row and third row are going to be similar.
I'm
That is why it
sorry.
is 0. You are right. The answer is correct without any issue. So I hope you get an idea of solving these type of questions.
Yeah, that was pretty helpful.
Okay. So this exercise 3.7, you please consider this as a homework. Okay. You must be having the book. So I'm just
Right.
looking at the book. Next, let us just quickly discuss this higher order derivative. They are not going to be different. Whatever you have done, it is the same thing. First of all, try to note down the notations. So these are the notations we are going to use.
I see.
Okay, y equals fx. So the derivative, first derivative is dy over dx. Second is d2y over dx square. Remember how I'm reading it. Third is
Yeah.
d, it should be 3 basically. There is a
It should be.
mistake.
Yeah. Yeah.
We will call it d3y over dx cube.
Yeah.
Okay, and it is y1, y2, y3, simple as per the notation. It is not a big task for you. So we have a first question. That means do the derivative first time, then do it again. Simply, it is the second derivative. When you do it again, it is the third derivative. If you look at this question, please help me with the derivative of cos inverse. I have told you already what is the derivative of cos inverse. It was there in a question. Do you remember?
Uh, 1 over, sorry, minus 1 over 1 minus x squared square root. Yeah.
So 1 over square root of 1 minus x square is the derivative of sine inverse, and this is the derivative cos inverse x.
Yeah.
If I ask you to do the derivative once more on both sides, it will become the second derivative minus 1
Yeah.
as it is d over dx of square root of 1 minus x square. Just simplify the right hand side. Left hand side we will be denoting it by dy over dx square. Simplify, do the derivative on the right hand side. Tell me this will be your final answer.
That would be 1 upon 2 into minus 1 over x squared to the power of minus 3 over 2.
So it is going to be 2 square root of 1 minus x square multiplied by negative 2x. Okay. So this will be your answer, but this answer is incorrect.
No,
Is there any?
my answer was not that. My answer was 1 upon 2
No, no.
into
It is
1
going to
minus
be.
x squared into power of minus 3 upon 2.
This is going to be the answer. Am I right?
The second prime.
Yes. Double derivative actually.
Okay.
Okay. Now, actually, the question is, we did it correctly without any issue. The question is, get the derivative in terms of y only.
Hmm.
If this is not the part of the question, my answer is correct. But because this is the part of the question, whenever you see something like that, that means to say that I wish to rewrite the expression like x equals gy. This is how I should write like. So y equals cos inverse x may be written as x equals cos y, right?
Mm-hmm.
Let me tell you once more. Whenever you see expression like get the double derivative in terms of y only. So try to write down like x equals cos y. Please do the derivative with respect to x. Derivative x is 1. Derivative cos is going to be how much? Negative of sine y multiplied by dy over dx. Do you agree?
Yeah.
So from here, my dy over dx is going to be negative of cosec x. Can you please help me to get that double derivative from here?
Um.
Oh, sorry, it is y.
Yeah.
You need to simplify this expression d over dy of cosec y.
Hmm.
The derivative of cosec y is going to be
Uh,
cosec y is going to be how much?
Wait one
Oh,
second.
it is going to be negative of cosec into cot
Oh, okay.
multiplied by dy over dx, right?
Yeah.
And from here, this d2y over dx square, it is going to be negative, negative will make it positive. We have cosec y into cot y. What was dy over dx? Dy over dx can be obtained from this expression. It is going to be negative of cosec y.
Yeah.
So when you simplify, this is going to be negative of cosec square y and cot y. This is going to be your answer. So we have not done anything special here. Simply did the first derivative and then did the second derivative. The only difference is earlier answer is correct. Yes, it is correct. Okay, it is just simplification, and we got the double derivative. But if whenever the question is in terms of y alone, then try to write the expression in terms of x, like x equals something. Then when you solve, like in the second step, you can see there is no term relating to x,
Okay.
and therefore this x is going to be removed. Okay, you will be able to find these type of terms maybe in the exercise there. No doubts.
Hmm. Yeah. Excellent.
So after this, there are some questions. You can just give it a try. Look at the question.
Hmm. Let's see.
Y equals x square minus 1 power m. Then the 2mth differential coefficient of y. 2mth derivative you need to find out. Are you getting the point?
Yeah.
So when you simplify the expression, this is going to be a binomial expression. This is going to be your binomial expression. So I need the value of this d, sorry, d 2mth time derivative of y with respect to dx whole power 2m, right? In order to get this expression, let me just try to tell you something. Can you please help me? Just suppose There is a term y equals to x cube is there. What is the derivative of x? What is the double derivative of x? Is it going to be 3 into 2 into x? Am I right?
Yes. Yeah.
What is the triple derivative of x?
6.
3 into 2 into 1, something like that. That is 3 factorial.
Yeah.
And what will be the fourth derivative of x?
0.
Okay. So in the expression, you can see the first term is of degree 2m. The second term is of degree 2m minus 2. The third term is of degree 2m minus 4. Am I right?
Yeah.
And keep going. So remember, when you do the derivative 2m time of a polynomial expression, the polynomial terms having degree less than 2m, the derivative is going to be 0. So for this case, I will be discussing the derivative of mc0 x power 2m only, and rest of the term will contribute 0 only. Why they are 0?
Yeah.
Because see the observation, the fourth derivative of x cube is 0. It applies to all. So whenever you differentiate a term, polynomial term, more than the degree of that term, you will be getting a 0. Additionally, what was the degree of this term? 3. When you differentiate 3 times, what you get? Whatever the exponent, you are going to get that like 1, 2, 3. So keeping MC0 as it is, what is the first term? 2m, right? What should be the second term? Second term is just minus 1, 2m minus 1. What is the third term? Again 2m minus 2 there. Any doubt there?
No.
Where it will go? Where it will go? It will go up to 3, 2, 1. So basically you will be getting MC0 2m factorial. This is going to be your answer. This may be a little bit tricky for you for the moment because I'm not sure if you are familiar with this kind of expansions. Are you familiar with this binomial terms?
Little bit.
Little bit. Okay, so no worries. Just forget about this question. There are some questions given to you based on the same. This is going to be something important. Please try as much as you can, and maybe we can take the doubts. And the next is going to be functional equation. We will discuss functional equations in the next class.
Okay.
Okay.